All right, the next section of our polynomial review is going over the short answer questions that you will take in class. So these are not necessarily capstone preparation questions, although they will definitely help you prepare for the capstone. But for these problems in class, you will have to show all of your work in order to get some short answer credit. So for number one, we want to graph each of the following polynomial functions and to label our x and y intercepts. So on part A, we notice that our polynomial function is already in factored or intercept form, which tells us where our x-intercept exists. So for the x plus 2 squared factor, I know that x equals -2, and it's going to bounce through that point. For the x minus 1 cubed factor, I know that x is going to equal +1 from that factor, and since my exponent is a 3, it's going to wiggle through that x-intercept. And lastly, for the x plus 5 factor, I know that x equals -5, and since my exponent is this invisible 1, I'm going to say it just crosses straight through that point. So if I wanted to, I could go ahead and plot those x-intercepts, and it might even be a good idea to put a C for cross with this one, a B for bounce at -2, and a W for wiggle at x equals 1, just so that we know what we're doing at each of those x-intercepts. Additionally, when we graph these, we need to know the end behavior, or specifically with end behavior, not necessarily so much the limit notation, but we need to know which direction the arrows are pointing at the end of this graph. So if I look here, I have exponents of 2, 3, and 1. And when I add my exponents 2, 3, and 1, I get an overall degree of 6, which means that it's an even power. There's a positive number in front for my leading coefficient. So that means my arrows are going to be pointing the same direction, and they're actually both going to be pointing up. Remember, even means same direction, positive coefficient means up on both sides. Then lastly, I want to figure out my y-intercept. And I know I have a y-intercept when x equals 0. So if I plug in the number 0 for x in my polynomial function, I can do some evaluating to see what the y-intercept actually is. Okay, so notice that all of these x's are being substituted with the value 0. So now I just need to evaluate. In my first parentheses, 0 plus 2 is 2, and 2 squared is 4. In my second parentheses, 0 minus 1 is -1, cubed is still -1, and in my last parentheses, 0 plus 5 is just 5. When I multiply those three numbers together, I get -20. So I know that somewhere down here, I have a y-intercept of 0, -20. And if I put my arrows for end behavior somewhere on this graph, I know both ends of this graph are going up. So again, when I graph these, I always start with my leftmost arrow and then travel through my points as they come up. Okay, so I'm going to travel to this first x-intercept. And when I get to that first x-intercept, I see the C there, meaning I'm just going to cross straight through it. Now the next point that I see is this x-intercept where I'm supposed to bounce. So somewhere down here I've got to turn around, hit that -2 x-intercept, and bounce right off of it. Then the next point I see, I need to come down and get this y-intercept before I turn back around to wiggle through that last point. All right, and now I have a good graph of that f of x polynomial function. This next function, you'll notice, is in standard form, not factored form. So standard form is nice because you can easily see the leading coefficient and the degree, which nicely tells us our end behavior first. So if I notice that my leading coefficient is negative and my degree, this 3, is odd, that means my arrows are going in opposite directions, and that generally from left to right, my eyes are looking down in the negative direction. Okay, then in order to get my x-intercepts this time, I need to try to factor this thing to get it in factored form. If we can't actually factor it, that means we'll probably have to use the rational root theorem, but I always like testing factoring first. Okay, so to rewrite this, in factored form, I'm going to factor by grouping since I have 4 terms. With this first group, negative x cubed minus 2x squared, I can take out or factor out a negative x squared. Then what's left over is an x plus 2. For this next group, x plus 2, the only thing I can really divide both of those by is a 1. So I'll take the 1 out, and again, I'm left with x plus 2. Okay, lucky for me, I see that x plus 2 occurs in both of those parentheses, meaning it's another GCF. So when I write this in factored form, I'll write my outside numbers, negative x squared plus 1 times my inside numbers, x plus 2. Okay, then from there, I want to look at this negative x squared plus 1, and I never want this negative to be inside the parentheses, so I'm going to go ahead and factor that out again, and have x squared minus 1 now, times x plus 2. And finally, I see that x squared minus 1 follows my difference of squares pattern. If I factored x squared minus 1, I take the square roots of each. So the square root of x squared is x. The square root of 1 is 1. 1 gets a minus sign, or a plus sign, 1 gets a minus sign. And again, we still have the negative out in front. Okay. So now I can very clearly see where my x-intercepts are. I've got an x-intercept at negative 1 with an exponent of 1, so it just crosses through. I have an x-intercept at positive 1, also just crosses through. And I have an x-intercept at negative 2, also just crosses through. So I've got my end behavior arrows, I've got my 3 x-intercepts here, and now I just need to figure out where my y-intercept is. Again, your y-intercept happens when x is 0. So if I plug 0 in for all of these original x's, you'll notice that these first terms don't mean anything anymore. They're just a 0, and we're left with the x-intercept, or the y-intercept at 2. So let's go ahead and plot the points that we know. I know I have a y-intercept up here at 0, 2. I'll plot my 3 x-intercepts. I've got an x-intercept at negative 1, positive 1, and negative 2, and it's going to cross through each of those. I'll add my end behavior arrows. And then again, going from left to right, I'm just going to connect all of these dots. So first thing I'm going to do is come down and cross through this negative 2. Then I've got to turn around somewhere down here. Don't really care where that happens right now. Cross through that negative 1 x-intercept. I have to come up and grab my y-intercept, then turn back around somehow and cross through my last x-intercept. And I'm going to just change my arrow position just slightly, but now we've got a good visual of that graph. All right, let's try question 2. Question 2 is asking us to use the following information to write equations in standard form. We are just writing general equations. We don't have enough information to write exact equations for each of these. But for example, on part A, I know that this function is a cubic polynomial with zeros of 4i and negative 1. Okay, so if I know I have zeros at, or if I have a 0 at 4i, I know I also have a 0 at negative 4i. So when I put those two zeros into my factors, the positive 4i is going to give me a factor of x minus 4i. Remember, it's always the opposite inside the factor. For negative 4i, I know I'm going to have x plus 4i. And for the 0 at negative 1, we're going to assume that comes from the factor x plus 1. So technically, I do have my polynomial written, but I want to have it in standard form, and I don't want imaginary numbers when I write it in standard form. So I'm going to start by multiplying my x plus 4i and my x minus 4i together. I know that x times x is x squared. X times 4i is positive 4ix. Then negative 4i times x is negative 4ix. Then negative 4i times positive 4i is negative 16i squared. And remember, we're still multiplying all of that stuff by the x plus 1. But before we get there, let's clean up this stuff in orange. I know that my 4ix terms are going to cancel out. So really, I have x squared minus 16i squared. But if you remember, I squared is really the number -1. And when we take -16 times -1, that turns into +16. So now I know I'm multiplying x squared plus 16 times x plus 1. Okay, so when I distribute with those terms, I know that x squared times x is x to the third. X squared times 1 is positive x squared. 16 times x is 16x. And 16 times 1 is 16. Now I've written a polynomial function in standard form with those specific zeros. Okay, so let's try the next one. Again, I'm given a cubic polynomial with 3 different zeros. So I'm going to start by writing f of x. My zeros are positive and -2. So for +2, I know that came from the factor x minus 2. For -2, I know that came from the factor x plus 2. And for the 0 at +5, I know that came from a factor x minus 5. Now, just like we did with the previous problem, we'll start by multiplying our first 2 factors. X times x is x squared. X times 2 is 2x. -2 times x is -2x. And -2 times +2 is -4. That all, again, is still getting multiplied by the x minus 5. But before we do that, we can clean up what we have here. The 2x and -2x are going to go away. And we're left with x squared minus 4, which is being multiplied by the x minus 5. Okay, so one more set of distributing. X squared times x is x cubed. X squared times -5 is -5x squared. -4 times x is -4x. And -4 times -5 is +20. And remember, you want to put your f of x equals in front so that we know it is still a function.